Good morning, everyone, and welcome to today's webinar, What's New in Creo 9? My name is Carolina Hägg, and I will be your host for today's event. And presenting today will be Mikko Hinkanen, our Customer Success Manager here at PTC Vision.
So, hello everyone, my name is Mikko Hinkanen and I will help today's presentation about what's new on Creo 9. So, welcome everyone from my behalf as well. So, let's go forward. So, today's agenda, we have 5 different subjects kind of on which we go through. First with the usability and productivity, then we go for design for ergonomics. Then we have a bit of model-based definition and detailing, and then for some simulation content, and then at the end of the presentation there will be some additive and subtractive manufacturing kind of fun parts. And let's go for the usability and productivity. First kind of fun thing is that Creo Parametric has basically 2 new features. It's called divide surfaces and unify surfaces. What it enables us is to split the current CAD geometry surfaces so that you will get separate regions in there. Previously, we have had this kind of a functionality in Creo Simulate where you can kind of make a surface regions, but that functionality hasn't been kind of exposed to the Creo Parametric side of it. Now we can. So we can basically split surfaces so that we can reuse them in this, let's say, simulation, in the regenerative design, model-based definition, also for the geometry creation and ascending appearance. So for example, on the right side picture, you have a kind of a tolerance, geometrical tolerance, which is limited only the left side or the right side of the piece. And it has been so far quite difficult to just limit kind of the scope of the tolerancing just to the right or left half. And now you can do that. Let's have a small video on this one. So in here, what you can see is the new functionality, and you will just simply click the existing sketch or create one on the fly, and then click the surfaces to be split. Select the side of which is the kind of the new feature, and as you can see, the color is now changing. On the other hand, if you have these pre-made sketches, you can use the existing functionalities like a sketch regions to select which kind of a loops do you want to keep, and then go and select the surfaces that you want to split. So this enables you to make markings, like for example, painting or limiting tolerances, or let's say, like as you can see, the yellow fixture, maybe pointing out that these are the surfaces that you should touch or you shouldn't touch at all. And it makes it quite fast and easy to use. Then a bit further with the demo, we divide a bit more surfaces just to show you the functionality and kind of like that it exists. In here, we have just a horizontal line, and then you can have another kind of a selection of the bodies. In here, you pick the top surface and use the shift key for the loop surfacing, and you are able to split the whole piece on the horizontal lane, which then enables you, of course, deciding which one kind of a side you want to keep as a new surface, accept it, and have a new color in there. Then a bit forward with the video. As you can see, if you go for query selection, what you will have is the intent surfaces in there, which you can then pick. So basically all those splitted surfaces becomes one new intent surface, which is then easy to pick. Should your design intent change, you can then, these things will always update accordingly. And then we are using something in here. As you can see, those yellow geometry penetrates to the blue one. And what we do is the insert curve, which kind of highlights the intersection volume between those two, then make a cutout so that basically you just subtract the jig away. And now the idea is that, okay, what we'll do next is to basically hide the kind of piece the jig geometry, and then mark those areas where the jig is touching or tooling is touching with a different color. So what we have there is those intersect curves, which we have already selected, and then you pick with the surfaces basically all the solids in there, and then you just select that, okay, these will be new ones, and then we will give a color for them. On the other hand, what we can also do is that you can use a reference feature to basically designate those surfaces that these are exactly the one that we want. So make kind of a reference feature in there. As you can see, there's also an intent selection available for this split surfaces. And then again, we do some coloring using that reference feature. bingo. And then at the end of this video, what we'll do is use divide surfaces feature to write some text to the side of the thing. And of course, you can just split the surfaces and make it available like that. Or then on the other hand, what we can do is make it a geometry to extrude or basically cut. And as you can see in there, we wrap the text around the piece. And then since you have that text as a curve, and then what you do is split divide surfaces. You have that curve in there already in place on the dialog. And now what we do is pick the corresponding surface, select the side if needed, and that's what you have in here. So even though it's kind of, how do I say, quite elementary to split the surfaces, but you can have quite many use cases for it. When it comes to regular modeling, model-based definition, simulation, or some other use you might come up with. So it's a kind of a, how would I say, new kind of a tool for your tool chest, so to speak. Then additional changes. What we have today is kind of a model tree changes, and first thing is the kind of a quilt/body evaluation tree. And if you tick in here the automated snapshot kind of a functionality on, you will see that how your model is being built over the kind of feature history. And sometimes when your feature trees are very long, it starts to be quite tricky to know that, okay, which is the quilt that I use to merge on each one, what is the outcome of it. And now when you click it, you will see that, okay, this was the original surface, and before it looked like that, and after merge it looked like that. So you see kind of the starting point of those. How did the surface look before the merge operation, for example? As you can see, those two cubes, and in here it's merged together, and in here it's merged to that bigger surface. So it makes it much easier to people to understand how the thing was modeled, on what order, how the features are kind of related to each other, and okay, if those are the kind of quilts and bodies, how do they relate on the corresponding features on the model tree? Where are they? Then there is an additional tree called design items tree. What we now support is a custom groups, where you can put a lot of things in there, like feature groups, patterns, and so forth. Then the basic model tree, we have new comments in there. If you click something, you can state, on the screen or under the model tree, you can state that, okay, I want to insert something, a feature, before or through the body/quilt. And it makes it much faster to access to the particular feature tree geometry. So kind of general handling of the things is getting a bit better nowadays. Then we move forward. Small kind of fun usability things. The sketcher, there's a new thing called auto scale first sketch. It means that when you sketch something on the sketch plane, of course the system will automatically make it fully dimensioned. But when you start altering the first or modifying the first dimension on that sketch, everything gets scales based on the ratio between the original and the new kind of a dimension. And that kind of a scale most likely scale the sketch on the proper size. If you don't like that kind of an upgrade, you can of course make the previous behavior existing using a Computer Pro option. Then what we have is a modernization project tool and the offset edge tool, and it means that the collectors has changed, and it's now there's a bit easier to understand that what did that pick, the kind of edge chain or from to or kind of a loops. How do you select stuff when it comes to projecting edges to the sketches? Then these inspection tools where you can see that, okay, here is we have intersection points, we have overlaps in here. This has been making a small overhaul that it's easier to see that where are the sketches failing, where are the overlapping lines. Then we have a complete new kind of feature. It's called curve from point. It simply means that you just pick a point on your design, and then you give out some kind of a direction. Where do you measure? And then you say that where on what I want to run the curve. And you can nowadays state that, okay, this is the starting angle, and the curve runs with the minimal potential distance on that surface with that angle on it. And it gives you some possibilities to make it a bit more guidable rather than just have a geodesic curve which can start to a bit funny direction from your design point of view. Then what has happened also is that the pattern functionality has now increased flexibility. What we can do is, for example, hole features, we can change types from the standard holes to the kind of a simple holes and back and forth. Also, the options required for the regeneration in here, we have this classical thing like we have a general pattern or identical pattern, and of course the generation time will go faster. And system nowadays tries to automatically detect if the identical is possible or not. It is such a way of how holes are computed. So general performance tuning in the Creo Parametric on that behalf. Then we jump directly to the surfacing side of it. So the style feature nowadays, where you are doing kind of aesthetically curves using a splines, we have a new kind of possibilities now to modify things and constrain things, and also we have a so-called acceleration control in here, which means that this is not tangentially continuous, it's not curvature continuous, it's a change of curvature kind of connected to the surroundings, which make kind of transitions between the pieces very, very smooth. And now you have new possibilities of tracking those points. Then we have a freestyle, which is kind of this subdivisional modeling. And that subdivisional modeling, there's a possibility that you can have a, let's say, STL file or something like that, kind of an OBE file at the base of it, and then system automatically maps kind of this spline surface on top of it. And sometimes the results are okay and acceptable as it is, but sometimes you have to start modifying using those control points. But picking the individual control points can be a bit difficult sometimes. So we have introduced a brushes in there, which just simply means that you just click in here, kind of a brush user interface, let's say inflate or pull, and then you just hover over here with the left mouse button clicked on, and the system starts automatically kind of a paint on it, and so pull the surface as a whole rather than individual control points or edges. So it's kind of a new way to make that rapid, very, very smooth operator, make it kind of look very kind of a continuous curvature thing, rather than that it would have a small kind of a waviness in here. Another thing is that what we have is the mirror is now possible for the freestyle shapes. And that makes kind of very nice applications for the med device, where you might just have a left side of the let's say X-ray, which is now intact, but on the right side you might have some broken bones or stuff. So you can basically model everything on the left side and mirror it out to the right side, and you will get your implants or whatever you might need. So now use cases in the med device on that. Then some general usability and productivity enhancements. We have enhanced our ECAD, import support, and nowadays the silk greens and the solder mask out there as well. Previously they were kind of non-existing. This just means that all the markings for your PCB plates are there on basically also the areas that will be covered with the protective pads are also in there. Then the small kind of a thing, but sometimes a bit annoying, has been that when you replace a component in assembly, let's say you want to replace a part with another part, yes, we can do that. But when the object type changes, like you want to replace the part with an assembly, it hasn't been possible so far. But nowadays it is. So you can replace an individual component like a part, like let's say a screw, with the assembly that contains that screw. Or another one. And the idea in there is that it will take care of all the kind of fun downstream and upstream kind of fun dependencies, including the drawings. Then we have some enhancements if you have missing components while you're retrieving your models, and you get a bit more information about what's missing and where. Then sometimes if you're doing some programming or let's say relation-driven things, you need a session EDS in your models. And nowadays you can show them in your model tree rather than going to directly to relations dialog and trying to find them in there. And then one last assembly kind of enhancement is that so far, if you have had an offset lines in your model tree, and there can be a lot of them, they have been individual assembly features, and you haven't been able to group them anyway to make the model tree look a bit nicer. But nowadays, those offset lines are also groupable features, so we can do that as well. And then we have access to circular references report directly from user interface rather than going to the hard drive and to find out the CRC file to find out that, okay, what is causing the circular references. So easier to find out the issues in the model basically is what you get with this one. Then we will jump to the new kind of a subject called design for ergonomics of this basic kind of a catting. An idea is in here that we have had mannequins which comes with a standard size and standard kind of a population. You know, you have average height, average, you know, weight and average kind of a weight kind of a thing. But should you have a specific need for trying out, let's say, how big or small somebody can be in order to fit somewhere, you can nowadays customize these things. And as you can see, when you're inputting a kind of a new numbers in here, the fellow at the right will change to print charming, so to speak, and be exactly the size that you want. And of course, what this makes it easier is that you can now today store these fellows as well, and you can create your own libraries based on that. So should you have a specific need of, you know, maximum size of, let's say, internet device size of patients, for example, that, you know, what you might want to have, that's now possible to tailor those mannequins a bit easier. Second thing is that we have improved the handling of those mannequins, that, you know, how easy it is to reach, how easy it is to kind of touch somewhere, how it is to manipulate those limbs. And now we have a bit different kind of fun behavior on the mannequin manipulation. Then one other thing is visual feature. It simply means that we can nowadays create this kind of a surface shape starting from the point and going for some direction, and this will represent the field of view. What can you see? And as you can see, the dashboard is now coming through that one. So if we just add some obstruction objects in here, you will get a bit more limited view of what you can actually see from that particular point. And of course, this will help you to design things so that it's visible, or another thing is that, you know, somebody else is not able to watch the same thing at the same time, or is possible. So it's kind of helping you out of making the devices approachable, and so that your human interaction with the device is getting better, and also find out faster, earlier, the potential kind of fun blockades of what can't you see, what can you see, what should you see situations in there. Then we will jump for model-based definition, and there's quite many new things in there and detailing as well. When it comes to surface finishing, let's say that the symbols have been in the, you know, a bit of upgrading so far, required a bit of upgrading due to the fact that the standards have been changed as well for the surface finishing. And now PTC has provided a very nice set of tools to put those surface marking on, and also to support the latest surface finishing standards in there. And I have to admit that, you know, when I looked this first one, I couldn't even tell what on earth is going on the symbol, since I just really have to read through the standard as well. So the marking has been changed a lot. Also, the way that you put it in the symbols has been changed. What else there was? Oh, it's a semantic support for this surface finish. This simply means the semantic support that when you have applied the particular kind of a notification in here, we will also collect all the surfaces that are affected by it. So it's not required that you put the same symbol 55 times in here. One symbol is enough, and then you can collect the surfaces where it is applied to. And you can ask it vice versa, click the symbol and say that, okay, what's affected, and on the other hand, another way around as well, that what is affecting this symbol as well. And as you can see, the scaling of the things and the orientations and everything is a kind of overhaul in this Creo version. And as you can see, the basic surface has now been added in there, and now we apply a bit more, all the intent surfaces, and then you add even more surfaces to it. So that all of these are affected by that one symbol. And then you go for asking, okay, what is affected, and you will get the visualization of it. Further on, then something new. We have possibilities nowadays to push in parameters to symbols. And why would we want to do that is that we can store this manufacturing process specific information on those parameters. And especially when it comes to weld symbols, then they are later on supported by a Winchell NPM link, so that we can get let's say welding time or required, kind of a devices related information from that, so that we can design then our welding process a bit better and support that on the manufacturing kind of a process design. So you get kind of a direct information of how to weld, what to weld, and so forth, directly from the symbol to the windshield. And in here, if you take a look what's happening, you will see that there are some parameters on the symbol, and yes, they are kind of pushed away. I'm sorry, now let's put the weld in there, and you will see the weld symbol, what is happening in here. I'm a bit too fast today. So first we make a fillet weld in there. You get the surface representation of it. You put the A dimension 0.1 inches, I think. And then if you take a look at what are the parameters for that particular weld, you will find out that A size or fillet weld leg size is in there, 0.1 inches. And should you want to go and change that, of course, the parameter information for that weld will change as well. And as you can now see that you can also designate these parameters and symbols and make them as a control characteristics, which basically means that they will appear on the windshield side as well. Then we move forward. The hatching in the detailing and drawings have been changed. Now we support a bit more broader kind of a, let's say, collection of the hatches, hatch patterns for the ANSI and ISO standards. And also what we have is kind of a hatch designer, which enables you to create your own kind of a patterns if you want to do that. And also the model tree has been kind of enhanced to basically inform you that what components are included in your kind of a cross-section creation, what kind of a cross-section do you have for each component in there. So it's a bit easier, or let's say you have more tools to manipulate the exact one cross-section, that what is kind of a visual there and what is not, and how do you modify them. Then the tool called GDNT Advisor, so you put the geometrical tolerances to drawings or MPD models. So far, we've been, well, this tool is kind of an extension for the Creo Parametric, and the general idea is to help the designer to put a non-conflicting tolerancing in the system. And today's enhancements are that we can basically create more dimensions on the fly if something is missing, more designations on the fly if something is missing, while we are checking through the piece itself. So basically this just helps to implement the MPD approach for the companies, so that when you create those dimensions and stuff, they are always coherent, so that there is no conflicting interest of them, and there's enough of tolerances and base elements and all that. So far the ability to create dimensions on the fly or tolerances have been missing in there, but now we support that as well. Then for simulation, and after that we go for manufacturing. So bear with me on these slides since we jump between the applications. Simulation in here, we'll go through multiple applications, 4 of them if I don't recall it wrong. Idea is that, Creo answers simulation. Basically, this is the applications that what we do for structural simulation. And what's new with the Creo 9 is that you have capability of creating mid-surfaces in there. So should you have a solid model at the beginning, now today you can create cells out of that. Second is that we can have bearing loads, which simply means that if you have a hole, you have it's kind of a non-constant bearing height, let's say load height in here. So it starts from the 0, goes to max, goes to 0, and the resultant of this force is what you want or as a load. It gives you a bit more of a better idea about how to simulate kind of pin/holes connections. The new thing in here is inertial relief, which simply means that some mechanism kind of components like this can basically move in the space, kind of all the directions. So how do I constrain it? Well, one of the ideas is put it in the force balance and let acceleration field take care of the rest, basically. So it's kind of easier to create simulation for those a bit harder to constrain models, but of course it's not applicable for everything. And then general usability enhancement for the Creo 9 and the Creo simulation is the copy paste, and you can use a number of cores, define how much do you want to use in the user interface. Previously it was quite well hidden in there. And also probe simulation and a bit easier and so forth. So it's kind of a general performance tuning, I would say, for the Creo simulation, plus that mid-surface capabilities. Then we have Creo Simulation Live. And what's there is basically, what's the difference between that is that in here we compute in the GPU card, all the stresses and strains and deformations. And now what's come with Creo 9 is multiphysics. So you have a capability of giving out thermal stresses. So basically a temperature field, which is then causing temperature expansion, and that is driving the stresses of the piece. So you can have that as well. Contacts will come at the Creo 9 first maintenance release, basically. At the moment, the initial release, they are not yet there. Then we have a lattice feature support for fluids, which simply means that if you happen to have a heat exchanger like that, and you have this formula-driven kind of lattice in there, and this is generating you voids, we can today simulate that as a heat exchanger or just basically a flow regulating device. And of course, if you take a look at this, it takes kind of a lot of meshing power to make it happen. So it's a bit harder to, has been a bit of a struggle to get these kind of thin-walled things in the fluid domains to be meshed properly, so that we don't get the flow directly through without observing the buffers in there at all. Then we have a third product called Creo Flow Analysis, and at the Creo 8, we had capabilities of just having a one project on per assembly. Now we have a multiple. On the other hand, we have tessellation improvements, which means that when you initially take the geometry, it will be tessellated. On top of that tessellation, we are making the mesh. Now we got some improvement in there to make sure that you get your mesh, you don't get any geometrical issues for that. And in here as well, we do support the lattice geometry in there. What's nice is the behavioral modeling integration, so that you can drive the model to, okay, simulate me something, then get the results, and try to first of all find the optimum of something, or make a parameter sweep that if I increase this kind of opening, what will happen to, let's say, fluid flow, or the, let's say, pressure drop over the system. You can get your graphs and try to find the optimum point of your design. So that's nice integration in there. And then we have a nice thing in there, which is basically a unit support. It makes it easier to put in the stuff in the correct dimension, rather than just having an input dialog with the number, and you have to basically deduct from the unit system about what is the value in here. Then the new thing, the generative topology optimization. Previously, what we did was optimization pane on the minimized strain energy, and the target was reduce the mass of, let's say, 50%, but try to basically to minimize the strain energy. That didn't guarantee that the stresses wouldn't go high, but now we have additional possibilities that what you have is a factor of safety, which basically limits the stresses to acceptable level. Then on the other hand, you try to minimize the mass in there on the side. So system then tries to find out the model that is having a reasonable stress levels, but on the other hand, minimize the mass. So it is getting a bit kind of a more engineering, how would I say, direction with that one. As a new ones is the features is that we can nowadays have a model optimization. So let's say that I want to have a piece that is has a minimum mass, but doesn't have the first kind of a model shape before the, let's say, 60 hertz, then that is what I can do today. So for some design, it's very important that the vibrations are not coming to as an issue, even though we are looking for minimal weight design. And then additionally, we support now the ball joints with some capabilities of like making translations or rotations fixed, so enabling you to kind of describe your process or device a bit better. Then we jump to the last subject or the area of the day, like additive and subtractive manufacturing. And what's now today is possible is that we have support for open quilts for stochastic lattices, which means that if you have some med device need for, let's say, this hand, and it can be that this is just a surface model, you can wrap around a mesh around it and make your product or supportive system with that. Then on the other hand, we have quite nice features for creating this a bit funny or let's say modern looking heat exchangers where you have a formula driven lattices, which then kind of creates two different domains, one for the red fluid, one for the green fluid, and that is basically a heat exchanger then. And it is quite efficient to create it in that way. And also we have a possibility of creating a user-defined support structures for the Creo 9 as well. Then with the high-speed milling and one of the last slides, what we have in here is the capabilities of okay, it seems my texts are still quite funny. The texts are for the previous slides, so let's see. Idea is that we can do this kind of geodesic machining kind of paths, especially with the 5-axis milling. It's getting a bit complex to make kind of a constant kind of fun step rate final kind of fun milling path in here, which then doesn't collide or gouge to the piece at all. And what we see in here is that if you just select the surfaces, and of course you have to select the approach direction and some, milling strategies as parameters, what is possible is to go around this thing without so that the tool head doesn't start to jump around and gouge the piece or let's say collide with the workpiece. So there's a plenty of option of the how do you avoid and how do you define your strategy in there. Shall we jump a bit forward with the slides? And as you can see, well, not that much maybe. We will go around the piece and gradually driving ourselves to that let's say cuttable metal, and of course it depends on your work in progress model, what you have, how much will you cut at each slide. But with some softer materials you can really do it like this. With some harder you can't. But as you can see, the milling head is not really jumping back and forth. It tries to give you a pretty constant kind of angle while it's circling to the top of the piece. And of course, what this makes the overall is make it easier for kind of fun non-expert user to create milling paths that really fulfills the needs of your. Then the one of final thing is that nowadays we can color the tool path based on the feed rates. We can also add tangents or circular extension in turning. And also one of the interesting things is that we can have a user-defined parameters in NC sequences. And what does it really mean is that if you have these before, you are basically limited to the existing commands or existing parameters while trying to push in some new information to your kind of facile data. And this basically gives you an capability of fine-tuning your post processor so that you can have your own kind of a comments text or whatever that you might want to have, so that you can guide your post processor to even more, to give out a bit better kind of fun building paths for yourself. Now I think it's time for Q&A sessions. Do we have some questions, Carolina?
Yes, we do. We have a question here about field of view. Is the field of view only for the mannequin, or can it be used for other functions like a camera, for instance?
Yeah, it's not mannequin-based thing, even though my PowerPoint slide had that driver head in there. It's not related that. It's basically you give out any point you want and direction, and then you just basically let the feature work from there. Not mannequin related. You can work with camera as well, and basically any sensor, so to speak.
Great. And then there was one question where where can I find out more about Creo 9? But I actually just put in the chat that if you have any question, if you want to know more about Creo 9, or if you want to join us for our next deep dives, you can just click the link here in the chat and it is available. And we have one more question. Is it possible to select part bodies in simply representations?
So that you would like to have a simplified representation where you just pick them based on per body, what bodies are visible. Haven't honestly tried that, but hey, I will cover that on my deep dive on the 15th, so then we'll know.
19th.
Sorry, 19th.
Yeah. Okay, but great. And I hope to see many of you on the next deep dive, 19th of May, 9 a.m. So thank you so much, Mikko, for this presentation. And I hope everybody has a nice day and great week. Okay, thank you so much.
Thank you, everyone.
Bye.
Bye.